Hello, in the past videos we have shown that, well, we know that the dot product u dot v, right, is equal to magnitude u magnitude v times the cosine of theta of the angle between the two. But if you do a quick solve for the cosine of theta, you could show that the cosine of theta is be u dot v divided by the magnitude u magnitude v, where theta is the angle between the two vectors u and v. So we can use the dot product, basically, or another form of it, to calculate the angle between certain vectors, right? And this works for both two-dimensional and three-dimensional vectors, where if we take u and v, then the cosine is going to be the dot product over the magnitudes in a two-dimensional vector, and it works the same in a three-dimensional, where we take the dot product of the three-dimensional vector and then the magnitudes of u and magnitudes of v, and so on. So we're going to use that to be able to solve a few problems. So the first example we're going to look at is example 33, and it says given u is the vector 2i negative 3j plus 4k, and v is I minus j minus k. Find the angle between the vectors u and v. So first thing, to be able to use a formula, I'm going to find the dot product first, and I'm going to do the algebraic one. So it's 2 times 1 is 2, negative 3 times, that's positive 3, and then 4 times negative 1 is negative 4. This is going to be 5 minus 4, which is equal to 1. And then I can find the magnitude of u. I'm going to write it down here. Magnitude of u is going to be the square root of 2 squared is 4, negative 3 squared is 9, and then 4 squared is 16. And this is going to be square root of 29 is what that's going to come out to be. And then the magnitude of v, of vector v, is going to be the square root. 1 squared plus 1, negative 1 squared is 1, so it's basically 1 plus 1 plus 1, which is root 3. And then I can use I know that the cosine of theta, the angle between these two vectors, is going to be the dot product, which is 1, and then it's going to be root 3 times root 29, and then I can find out the angle by taking the cosine inverse of what this is, which is 1 root 3 over root times root 29. And here's where I'm going to use the calculator. Bring the calculator, come on, and I'm going to go, let's see, I'm going to go trig cosine inverse ratio 1 over root 3 times 29, and it's going to come out to roughly 83.4 degrees. So this is going to be 83.4 degrees approximately. Sound good? So there we can use the dot product to find the angle between the two vectors. Next problem we're going to look at is example 34, and it says find the values of k, which the angle between the two vectors u is 1k and 1 and k, and then the angle in vector v is 3k2 is 60. So we know that the cosine of 60 degrees is going to be the dot product of these two, so that's going to be 3k times 1, which is 3k, then 2 times k, which is 2k, and then we're going to have on the bottom the magnitude of u, which would be 1 squared is just 1 plus k squared, times the magnitude of that's going to be 9k squared plus 4, right? And then I know that the cosine at 60 degrees is a half, and this is going to be equal to 5k over, I can write the square root 1 plus k squared times 9k squared plus 4. And I'm going to go ahead and use a calculator to the solver to help me get the answers for this. So I am going to do menu, algebra, numerical solve, and I'm going to go 0.5 equals, have a fraction here, so I'm going to go 5k over the square root 1 plus k squared times the root of 9k squared plus 4, and I'm going to I have to assign what value I'm solving for it, so it's comma k, and I get k is equal to approximately 0.2149, and there ends up being a second answer, so I'm going to go ahead and say comma 1, and I get my other answer, which is k is equal to 3.1016 approximately, and so I got my two answers that way, and I used the solver. Sound good, guys? Thanks.